Hello everyone, so as part of my leadership project, I'm going to be teaching physics along with Sajid and Andy. This will be the first lesson, 1 of 7, and we're going to introduce kinematics, displacement, velocity, and acceleration, and vector addition. So, as I mentioned before, we're doing kinematics first. Now, kinematics is a branch of physics that describes the motion of an object without actually going into the causes of the motion. That is called dynamics. That includes forces and energy, and we will go over that later. For now, we will focus on describing the way things move. Starting off really basically, let's review some concepts and terms from Science 10. In general, there are two types of values or quantities in physics. You have your scalar and you have your vector quantities. Now, scalar quantities are essentially quantities that do not have direction, okay? And obviously, the vector quantities are quantities that do have direction. These include displacement, velocity, and acceleration. So we have displacement, we have velocity, and we have acceleration. I apologize ahead of time for my terrible writing. Now, for scalar quantities, we have stuff like speed and mass and time. All those, they don't have direction. They only go one way, which is forward. I would like to turn back time as well, but clearly that's not an option yet, so it's a scalar quantity. So let's go over an example of where this might matter. So let's take this, for example, okay? Now let's observe this diagram. Let's say you walk from point A to point B, okay? And then afterwards you walk from point B to point C. So let's take a moment to calculate the distance that you traveled. So your resulting distance should be 700 meters plus 500 meters equals 1200 meters or 1.2 kilometers. Okay, so that's pretty easy. Now let's go calculate displacements, which is basically d with an arrow on top. In order to calculate displacement, you have to know what that means first. So displacement is basically the closest distance from your initial and final location in a certain direction. In this case, you move from point A to point C. Okay, so that is your displacement. So because this is a right triangle, we can easily use the Pythagorean theorem. For those of you who don't know or don't remember, it's basically a squared plus b squared equals c squared. Okay, and this is where c is the hypotenuse. So let's go solve for c. C squared equals a squared plus b squared, and then we can derive this here. Okay, c equals, and your a value is 500 squared plus your b value is 700. They're interchangeable, so it doesn't really matter. Okay, and your final value should calculate out to around 860 meters. Don't forget your units. And of course, we said vector quantities, they have direction, so we have to add that in. In this case, let's say this is 60 here. That's 60 degrees. So how we would say this is, this would be 60 degrees and the person is going south and then going east. So it would be 60 degrees, and that's east of south. So that tells you the direction of where it's headed, and that tells you the quantity of how much it got displaced. Okay, so what about speed and velocity? Velocity is essentially speed with a direction, but the more proper definition is the rate of change in location. This concept is slightly tricky to grasp, but just think of a train. It is moving north at 30 meters per second. Okay, so if it's moving north at 30 meters per second, it means that the eastern and the western velocities are 0. And it would mean that the southern velocity is negative 30 meters per second. It's a little more complicated than that once you add in angles. In fact, why don't we just do that right now? So in this same, using this example here, okay, let's say the time here, the time you went from A to B, okay, is 140 seconds. And that's the time to go from B to C is 200 seconds. 250 seconds. So in this next activity, determine the speed of each segment and the velocity from point A to point C. So speed is V. Let's use S for speed. Okay, S. Okay, S for AB equals to, and the formula for speed is obviously displacement over time. Distance over time. That would equal to 700 meters over 140 seconds, which would equal to 5 meters per second. Do we know how we got this unit here? It's basically meters here, because it's displacement, which is calculated in meters, over the time, which is calculated in seconds. So your final units would be meters per second. It's not always the case. Some other units like forces, even though it's mass times acceleration, it's still calculated slightly differently and it's calculated in newtons. Anyways, we'll get to that when we cross that bridge. So your speed for B to C would equal to distance over time equals to 500 over 250, and that's equal to 2 meters per second. So those are your speeds from point A to B and B to C. So what about your velocity, okay? Just like displacement, velocity will be your C value here. So to calculate that, you go C equals to the square root of A squared plus B squared. C would equal to 5 squared plus 2 squared, and these values you got from here. Okay, so and then you punch into the calculator and you get 5.4 meters per second, and don't forget units, so you go at 60 degrees east of south. So the thing is, when you solve for vectors, it's not always going to be, all roses and cherries. It's not always going to be triangles where you can just use the Pythagorean theorem. It's going to get a lot more complicated once you add more angles. In fact, why don't we do one of them right now? Well, why don't we do one of those questions right now? So you can go from, okay. So how would we add all of this? This is where we get into something called vector addition, okay? So there are a few steps to vector addition. Let's go write these down, okay? Vector addition. So step 1 is you take the vertical or y components of the figure and determine the sum total, okay? So afterwards, you take afterwards, you take the horizontal ones and then you add them as well. And then your third step is do Pythagorean theorem to solve for C, because it'll create a triangle. So for example, you take the vertical, you take the horizontal, you create a triangle, that's C, and you solve for it. Okay, so that sounds really simple, right? Because honestly, it's not. There are a few things you have to be careful about, and the most important one that you should worry about yourself currently is the direction in which everything is going. So in general, positive values are the ones that go up, that go north, that go east, or that go left, okay? These are the positive values. The negative values are the ones that go down, obviously, the ones that go south, the ones that go west, and the ones that go left. Okay, so, oh, and one more for negative. It's basically if the question tells you something is opposing something, or you're going in the opposite direction, that's a negative value. So like, for example, the train question that I had, I said it was going north, okay, at 30 meters per second. That means that in the south direction, it'll be going negative 30 meters per second. And another thing that you have to be careful about, I won't touch much into this because it takes a while to explain, is angled movements. Unless it's otherwise stated, you'll have to use trigonometry to solve for the vertical components and the horizontal components for the C value. Okay, so if you're given C value and you're given an angle, then you have to solve for A and B, which are your horizontal and vertical components. Yeah, more on that later. So let's solve this guy here. So assuming that one of these blocks is 1 unit each, we can calculate the horizontal and vertical components. So vertical component first. So we have this, which is, so let's label these A, B, and C. So the value of C is -3. The value of A, and we're looking for, we call this AY, is equal to, let's count 1, 2, 3, 4, 5, equal to 5. Okay, and that's 5 up because you can see the arrow is heading upwards like that. Okay, and now horizontal components. So the horizontal components are the B value and AX. Okay, so B is equal to 1, 2, 3, 4, 5. It's equal to 5 to the right, so that's positive. And then we have AX. AX is 1, 2, 3, 4, and that's 4 to the right, so that's also positive. So let's go add these. Okay. So -3 plus 5. That's 2. So -3 plus 5 equals 2. And then 5 plus 4 equals 9. So now we can, just create a triangle here. And then that's C. Okay, so, oh, hold on, my bad. I drew it wrong. It should be 9 this way, and then 2 upwards like that. Call that 9 and 2. With this, we can use the Pythagorean theorem to solve for the value of c. So c equals the square root of a squared plus b squared. C equals to 9 squared plus 2 squared, which is 81 plus 4 equals to 85. And square root that, we're given 9.2. Okay, now, of course, so that's 9.2 units. Don't forget your units, guys. That's really important, and you can lose a lot of marks for not having units. Okay, so that's that. And then now we just need to solve for the direction. How do we do this? Well, trigonometry time, guys. So we can solve it using tangent because we have the opposite value and the adjacent value. Let's solve for this here. So we have the opposite value and the negative or the adjacent value, not negative value. So we know this is angle theta, so theta equals to tangent of -1 equals to opposite over adjacent. And like, you guys are going to need to use a lot of trigonometry, so you know, if you don't know it, review it. It's really important. So tangent of -1, what's our opposite? That's 2 over 9 equals, so theta would equal to, and I'm just going to punch into the calculator real quick, 2 over 9, which is 13 degrees approximately. So it's 9.2 units at 13 degrees. And like, if we said this was north and this was east, then we would say that's 13 degrees north of east. Okay, are we cool? Okay, and there is one last concept I want to squeeze in today, and that is the concept of how all of this relates to each other. First of all, one more unit I have to introduce, that's acceleration. So the acceleration is the change in velocity over time. I'll demonstrate what this means in this next activity here. So assume, okay, let's say red is displacement. Blue is velocity, and green is acceleration. Let's go over a few scenarios using graphs here, okay? So that's good. Okay, the first graph is going to be a position time graph. And here we're going to plot our displacement, okay? The second graph is going to be a velocity time graph. And that's going to be obviously where we put our velocity. And the third one is acceleration time graph. And we will have 3 scenarios here. The first scenario is going to be constant displacement. Now, it's basically a stupider way of saying the object is not moving. So, if the object is not moving, okay, then it stays at a stable position. So, let's say that position is 3 from the origin, okay? That would be your displacement. So, d, displacement, equals 3 meters. So, now we have the velocity, okay? Now, it's not moving. So what does that say about the velocity? When a car's not moving, how many kilometers an hour is it going? 0. Okay, so your velocity will be 0, and it'll be a flat line. Now, we have your acceleration. If your object is not even moving, doesn't even have any velocity, okay, then obviously your acceleration will also be 0. Now, next up we have constant. I probably should not change colors. Next up we have constant velocity. Okay. So let's say the constant velocity is at 1 meter per second. So now we'll put it here. 1 meter per second. What would happen to the displacement? Well, here's what would happen. It would go like this. The reason for this is because it is increasing by 1 position for every second. So then for every 1 second, it goes that way. The position would increase 1 meter away from the origin point. Okay, as such, I'll get into this later actually. Next up is acceleration. Acceleration is still at 0, and that's because at any given moment, at any given second, the velocity is not increasing. So if the velocity doesn't increase or decrease, then there is no change in acceleration, so it stays at 0. So let's talk about some of these equations here. Okay, what would the equation for position be? Well, it would actually be displacement equals velocity times time. Okay, there are 2 explanations for this. The first one is this triangle here, which if you have taken Science 10, you would have known. It's d and then vt. Okay. Basically what this means is displacement would equal to velocity times time. Okay, but then alternatively, if you're looking for velocity, okay, it would be velocity equals displacement is on top over time, and the same would go for time. Okay, so d equals vt. The second explanation is it's like y equals mx plus b. It's a linear equation, therefore it has to fit within y equals mx plus b. So b is your y-intercept, which is 0, which is y. Well, I guess I could put plus 0 here. Okay, and then t is your x value, obviously. And then v is the slope. So the slope would be 1. So if we're looking at the position at, say, the 4th second, okay, 4th second, so your displacement would be d equals 1 meter per second times 4, which would equal to 4 meters. Okay, moving on. Let's say now we have a constant acceleration, okay? So the constant acceleration would be 1 meter per second squared, by the way, my bad. It's 1 meters per second squared, and that's because the units are meters per second. Okay, it'd be v over s equals meters per second over second. So when you have 2 s's here, meters per second times second, that basically simplifies to meters per second squared. Okay. What would happen to the velocity here if it's 1 meters per second squared? Well, it's basically what would happen to position if it was constant velocity. There would be a slope here. Oops. There would be a slope here. In this case, for every given second, it would increase the velocity by 1, okay? Now, here's where things get interesting. What would happen to the position of, or what would happen to the graph with the position time graph? This is how it would look like here. Okay. Okay, let's really quickly go over the equation for velocity here and displacement. So what would happen to velocity? Well, we have a different equation here. V over a t. This is a different triangle. So as you can see, velocity would equal to acceleration times time. So what would happen to the equation for the position time graph if there was a constant acceleration? Well, we are going to get into that next time, where we go over more equations and how to apply these into how to apply kinematic equations into word problems. Well, I hope this video was helpful, and yeah, I'll see you guys next time.